In this tutorial, we will be discussing the VSEPR theory. And the structure of a compound determines its properties. The chemical and physical properties of molecular substances depend on the structure of that species. There are a few factors to be considered when we're determining this. One is the skeletal arrangement of the atoms, so which atoms are bonded to one another. What type of intramolecular, so that's between the atoms of the molecule. Type of intramolecular bonding between the atoms, so ionic, polar or nonpolar covalent, and the shape of the molecule itself. Bonding theory should allow you to predict the shapes of the molecules. That brings us to VSEPR, valence shell electron pair repulsion, VSEPR. Is used to predict the molecular geometries of compounds based on the number of electron groups attached to the center atom of the molecule. Electron groups are referring to either bonds or lone pairs. Or if you have a single electron there, which is rare but can happen, it's referring to those two. So basically the electrons that are around the atom. Let's break down the term valence shell electron pair repulsion so it's not just words that we're rattling off. When we're talking about valence shell, we're talking about the outermost electrons. Because those are the ones that are actually reacting. They're the ones that are participating in the interaction between the atoms. Electron pair repulsion. Well, electrons are all not negatively charged. They all have the same charge. And as you know, opposites attract and same charge repels. They try to get as far away from each other as possible. So when we're dealing with here is we're talking about the outermost electrons, in which those electrons are trying to get as far away from one another as possible. And that's what it means by saying valence shell electron pair repulsion. The most important factor in determining the geometry is minimizing the relative repulsion between the electron pairs. Molecules or ions geometry reflect arrangement that favors the minimal electron repulsion, so where they're most relaxed. Molecules are three-dimensional objects, so their shape can be described in terms related to geometric figures. For example, we have linear, tetrahedral, and octahedral geometric shapes. And geometric shapes in general have characteristics, as do the geometric shapes of compounds. They have corners, which in our case, the corners will be the atoms that are bonded to it, that indicate the position surrounding the atoms around the central atom in the center of the geometric figure. Also, there's angles between them. Now, we were discussing Lewis structures in the past, previously. The Lewis structure is able to predict the number of valence electron pairs around a central atom. Each lone pair of electrons constitutes one electron group on the central atom. So even though it's not bonded to anything down here, we still have to consider it because of that lone pair. Each bond constitutes one electron group on the central atom. So these hydrogens here are also considered part of the groups. So when we're determining shape, we're looking at both the bonds and the lone pairs, regardless of whether it's a single, double, or triple bond. So what this is referring to is if we had a shape like this, we're looking at groups. So there's three things coming off that carbon. If we had a lone pair here, and it looked like this, the lone pairs would be considered one of those three things. VSEPR theory is based on the number of electron groups attached to the center atom of the molecule. The arrangement of the atoms attached to the center atom, minimizing the relative repulsion between the electron pairs. So this lone pair still takes up space even though you don't see it. Once you actually see it, those lone pairs go away. So this is the electron geometry of the tetrahedral. This is the molecular geometry. So the electron geometry we're including the lone pair. The molecular geometry we are not. The arrangement of the atoms attached to the center atom dictates the compound structure, which is the electron pair geometry, and the shape, which is the molecular geometry of the atoms. To start off with, let's start talking about the 5 basic types of arrangements. These are considered the families of electron groups around the central atom. When we're looking at families, we're pretending like we're looking at representative ones that do not have any lone pairs, because the lone pairs will affect the molecular geometry. We're just looking at before lone pairs are included. So the type of electron groups are atoms and lone pairs, but our basic 5 all have actual groups. And then these spring off to have different forms. So the 5 geometric families are linear, straight line, trigonal planar. Tri means 3, so we have 3 things here. Planar, meaning it's flat. It's in the same plane, like a piece of paper. Tetrahedral. Tetra is 4 things coming off of it. Trigonal bipyramidal. Tri, once again, so we have 3 things going around it. Pyramidal. So what we're referring to is if we were to fill in this structure, you will see it actually forms a 3-sided pyramid. It forms it at the top and at the bottom. So therefore that's why it's bipyramidal, because there's a pyramid on the top and a pyramid on the bottom. And then octahedral. Oct meaning 8. Well, the reason why it's calling 8 is because you can actually have a square around the central atom, and then you have one on top and one on bottom. If we were to connect all of those together, you have 4 sides on the top, and you would have 4 sides on the bottom, and that's where they get the oct from. And those are your 5 basic shapes. Now in the next tutorial we're going to break those down even more and include lone pairs, and that's actually going to change the geometric shape a little.